just a few more, starting with number 22. Number 22 says B equals 53 and A equals 12. And they give us this diagram to follow. So we'll do that. 90. This one's A, C, B, and then the sides would be little a, little b, and little c. And little a is 12, let's see, capital B, so that angle is 53. And they want us to solve this triangle. So you can see that you know this angle and you know this side, but you don't know this angle or these sides. Something pretty simple, you know this this angle and this angle, so you can find this angle. Let's see, it would be 37 degrees. And let's say we just want to use one of the ratios that involves an angle that we know, a side that we know, and a side that we don't know. So we could say that the sine of 37 degrees is equal to the opposite side over the hypotenuse, which is c. And then we could solve for c, multiply by c on both sides, and we have c times the sine of 37 degrees equals 12. And then divide by sine of 37 degrees on both sides. Okay. And 37, of course, is kind of one of those off angles that you don't have to memorize, so we would use the calculator for that. Here's my calculator. And 12 divided by, I'll show you what I'm doing, 12 divided by the sine of 37, making sure I'm in degrees, and I am, so 19.94. 19.94. For this, we could do, a Pythagorean theorem. B squared plus 12 squared equals 19.94 squared. I'm going to just go ahead and use the sine of 53. The sine of 53 degrees is the ratio, then the sine is the name of the ratio. That's the opposite over the hypotenuse. That's B over 19.94. Multiply by 19.94 on both sides. Okay. And we'll just go ahead and use this from the previous problem. Multiply it by the sine of 53. Give us a nice exact answer, 15.92. 15.92 for that side. Alright. Let's try another just like that, number 28. B equals 24, big B, angle B. Side C equals 10.8. And here's our diagram they give us. This is 10.8. This is angle C, this is angle A, and angle B is 24 degrees. So right away we know these two angles. We could find this angle pretty easily. That's going to be 66 degrees. 76 degrees. No, 66 degrees. 66 degrees for sure. Okay. And now we're going to use one of the trig ratios and a side that we don't know, like A or B, and a side that we do know, like 10.8. So the sine of 24 degrees, that's the name, the sine is the ratio of the opposite side over the hypotenuse, so that B over 10.8, multiply by 10.8 on both sides, and 10.8 times the sine of 24 degrees, that's 4.39. 24.39. A. Let's find A. Let's use 24 again. We've got the adjacent side and the hypotenuse. So the cosine of 24 degrees is equal to A over 10.8. Multiply by 10.8 on both sides. A is equal to 10.8 times the cosine of 24 degrees. We'll find out what that number is. Let's just bring this back. Change this to the cosine and we'll be good to go. 9.87. Alright, so this is 9.87. Easy as pie. Let's do a quick word problem here, number 31. So here's a piano with its legs like this, and the keys there. Its lid, I don't know if that's the right word for the top of a piano, but I'm going to call it the lid. They're saying this is opening up at an angle of 25 degrees, and all the way across the front is 150 centimeters. They would like you to find out the length of the prop holding up the piano. Well, it's not holding up the piano. It's maybe holding down the piano. It's keeping the piano from coming up. It's really holding up the lid there. So they want the length of this thing. Well, this is just a right triangle, 90 degrees there. So let's see. We've got the hypotenuse, got this angle, and this is the side we want. This is the side opposite this angle, so opposite over hypotenuse. The opposite, say, let's call this P for prop. Okay, the prop over 150 centimeters is equal to opposite over hypotenuse. That's the sine of 25 degrees. So 150 multiplied by 150 on both sides. 150 times the sine of 25 degrees. That's P. And 150 times the sine of 25 degrees. 63.39 centimeters. That's it. Okay, so keep in mind with all these problems, there are many different ways to solve them. You know, where I use the sine here, you could have used the cosine of 66 degrees. For this, you could have used the sine of 66 degrees. There's just lots of options. There's no one way to go. And that's a common feeling among math students is what is the right thing to do? What's the one correct way to go about this? And there may not be one correct way. It just requires an understanding of what these trig ratios are, which ratios they are, and applying them at the right time. Not the right time, but at an appropriate time. If the sine works, then make it work for you. If the cosine works, make that work for you. Just use them correctly. Kind of like you could use a screwdriver or a hammer to get a nail into a piece of wood. And a screwdriver will get the job done, but maybe the hammer is a little bit of a better choice. So I'll stop rambling, and you don't have to keep watching. Thanks for watching, though.